BC Chemistry, Unit 4, Primary Structure of Protein, Peptides. Recall that we have learned about condensation reaction in previous sections, where a carboxylic acid and amine can combine together through making a water as a byproduct and then forming a CN bond as a result and produce therefore a amide. Okay, so it's a reaction between the carboxyl group and the amino functional group. Okay, since all two amino acids have both amino functional group and the COO, and therefore they can have condensation reactions with each other. So, for example, two amino acids, glycine and alanine, both are on our data book. Okay, so the carboxyl group and the amino group, or carboxyl group from glycine and amino group from alanine, can come together and then lose one molecule of water and then form a CN bond. And therefore, as a result, you have what we call, when two amino acids form a amide together, we call it a dipeptide. This dipeptide has an amide linkage, or we can call it a peptide linkage. Okay? This CN bond, the bond itself is called a peptide bond. Okay? So amide linkage. Okay. So you notice that this particular dipeptide also has an NH2 group, also has a carboxyl group. It can keep having that condensation reaction. As long as I have another carboxyl group here, I can be attached to it. Or if I have another amino functional group there on the right, I can also be attached to it. So this condensation reaction can keep going as long as you have more amino acids to be attached to both ends, right? Sometimes people ask, well, how about the amino functional group of glycine merge with the carboxyl group of alanine? Can it happen? Of course it can. And the result just will be another dipeptide, okay, different from this one here. Okay, they're just connected in different order, but they can totally react in that way as well. Now, we said that different amino acids here can keep attached to this dipeptide and making a tripeptide and even more. Okay, as a result, what we will have is a polypeptide. Okay, so you can see that in this animation, the NH2 group and is marked in blue, and then the oxygens are marked in red. So different amino acids, through the same condensation reaction, can keep stacked onto each other and therefore form a polypeptide. Okay, so every time they stack up onto each other, they will lose one molecule of water. So the result is it's a polymerization reaction, right? So when many molecules come together to make a giant chain, sometimes through addition reaction, but in our case, it's actually through a condensation reaction. So by ditching water molecules, many units of amino acids can be stacked up onto each other and make a very long polymer chain. And each amino acid is the monomer of that polymer chain, that polypeptide chain. Okay? So if there are n units of amino acids linked together through condensation reactions, then there will be n-1 number of molecules of water be produced as a byproduct. And n-1 peptide linkage will be made. Okay. Once we made a polypeptide, how do we actually name it? Okay. So we name it in this way. Normally, we start with our left-hand side with a amino functional group. That's the amino functional group of the first amino acid in our chain. Right? That's the amino group there. And then we connect it through the first 3 letters of that name of that amino acid. So if the first amino acid unit is from glycine, then it's GLY. If it's alanine, then the second one is alanine, then we put ALA together. So we take the first 3 letters of each amino acid and write them in this manner, in a sequence. Okay. Then the polypeptide chain will finish with a Cu, which is the carboxyl group of the last amino acid. Okay. So that's how we name it. We don't have to pronounce it ever. Okay. We just, in this way, we're showing the number and the sequence and the type of amino acids that actually made up of that polymer chain. Okay. So remember that when we try to name a polymer, we always try to show what is the monomer that makes the polymer, right? Even though it's the same repeating unit, and then getting together through addition reactions, we also try to show the monomer. So here we're trying to show the monomer of basically all amino acids that make up the chain by using the first 3 letters as acronym. Okay. Now, polypeptides with 50 or more amino acids are called proteins. So this brings us to the primary structure of protein. So the primary structure shows the number, type, and sequence of amino acid units in a protein. Okay. So basically, this shows our primary structure of protein. So the number, type, and the name of each amino acid. Okay. By convention, the sequence always starts with the N-terminal, which is the amino functional group of the first amino acid on the left, and then it ends up with the C-terminal, which is the Cu on the right. Even though we know that we always number starting from the Cu, but by convention, we always put the N-terminal on the left and the C-terminal on the right. Okay. So the primary structure is linked together by CN peptide bond, right? It is a covalent bond, and therefore it's relatively stable, and it's least affected by change of environment. For example, temperature or pH. It's least affected.